This video will help take you through how to set up the BankDemo application that makes use of the high availability VSAM feature included in Enterprise Developer 3.0. The aim is that you can use this as a starting point for helping develop your environment for a high availability configuration. We will have 3 enterprise server regions that each serve as a node in the high availability group, as well as a 4th external CICS region. I already have the sample files here from the BankDemo, as well as the necessary directories for each node in the group. In the data directory, I have the BankDemo files that will be replicated across the group. In the config directory, I have the resource definition file that includes my transaction and file definitions, as well as an fhreader.config that is used with the external CICS region. I also have my loadlib directory, which contains all the built programs from BankDemo. It is important to ensure before we start up the group that the data files are in a consistent state between each region. We will achieve this by copying the contents of the data folder into the corresponding location for each node. Let's start by defining the ES regions that will form our high availability group. For each of the regions, we will specify a unique working directory for file share using the fs-workdir environment variable. If this is not specified, then the working directory will default to the system directory for the region. We'll also go ahead and define a TN3270 listener for each region for direct access. Next, we need to define the ES HA-VSAM variable. This tells Enterprise Server that this node is part of a high availability group. It's made up of various parameters. The first parameter is the mode in which HA-VSAM will operate. This can either be T for tracing, S for solo mode, or Y for enabled. In this example, we'll go ahead and use Y. The next block of parameters are repeated for each node within the group. Within this block of parameters, the first is the name of the ES region, so in this case it is HA1. The next is the name or IP address of the host machine that the region is running on. The third is the port of the ISC connection and simply needs to be a free port on the system. The ISC port connection must be unique for each node in the group, as this port is used to establish the connection between nodes. The fourth is the port that MFDS is running on in the host machine. Note that these blocks of parameters are separated by semicolons, and the individual parameters in each block are separated by commas. Now we'll go ahead and configure the CICS environment. This simply uses the BankSitI system initialization table, the files in the loadlib directory, as well as the resource definition file in the config directory. We'll also need to go ahead and add a file share listener. You'll notice that there is now a new option for file share when adding a listener. This is part of the integrated file share feature that has been added in 3.0 and must be used for a high availability configuration. First, we must specify a name for our listener. In this case, we'll use fs1. It is important to ensure each file share listener in each node has the same server name so that the connection can be re-established after a failover without manual intervention. Each node in the group should use the same configuration, with the only significant change being to the fs-workdir and system directory. The ES-HA-VSAM variable should remain the same, as well as the name of the file share listener. In this demo, we're also going to create an external CICS region. This will be the region that clients will connect 3270 sessions to. This region is set up just as an ordinary CICS region that uses the fhreader environment variable to ensure that access to the data files is vectored through file share. Having our enterprise server regions configured this way allows users to connect to the external CICS regions, while the high availability regions work to ensure that the files are replicated and can always be accessed. This means that should a failure occur on one of the high availability nodes, the user can continue operating as normal whilst the connections are re-established and data files are replicated in the high availability group. The next step is to go ahead and create the database reference file. This is similar to one you would create for a standalone file share configuration. However, the main difference with this is that it must be configured with advanced logging enabled, otherwise the high availability group will fail to initialize. We also need to specify the files that should be vectored through file share. We do this with the -f option. File share will search this as a relative path to the FS work there. With the regions now started, we can see that HA1 is marked as the primary node and both HA2 and HA3 are marked as standby. This indicates the regions have started correctly and that both HA2 and HA3 are ready to fail over and assume the role of primary should a failure occur in HA1. You'll notice that PLT processing has only occurred in HA1. This is because PLT processing can only occur once, so the standby nodes will not perform this until they assume the role of primary. You may note that the listeners for both the standby nodes have not been started. If we look, we can see the file share listener is marked as blocked. When the primary node fails, the next node that becomes the primary will unblock its file share listener, so any access through to file share can resume. This is why it's important to ensure that the file share listeners all have the same name. If we access ES Monitor and Control, you can see that HA1 is marked as the primary. Now let's take a look at the group definitions in CICS. We can see that the name of the file share server is blank. For the files defined to the high availability regions, this is correct as it will use the database reference file to ensure the files are accessed through file share. This option is only used for external clients in which an FH reader is needed. You will need to ensure that the files are marked as backwards recoverable, otherwise we will not be able to replicate them across the group. If we now take a look at the FCT definitions for the BankCICS system initialization table, we can see that the files are marked as backwards recoverable, but they also specify a file share server. This is the system initialization table used in the external CICS region. You may also note that there is a new option on the drop-down menu for iFileShare. We have now integrated some of the functionality within the FSView command to the new iFSView page. In here, we can perform various commands to retrieve information on the file share server, such as seeing the open files or the statistics. You can still use FSView on the command line to access these functions if you wish. We also have the new Control tab. This shows the current state of the high availability group, such as the connection status, whether the node is primary or standby, the host name of the machine, and the port that the ISC communication is established on. We also have handy links to the ESMAC pages of other nodes in the group. Here we can see that clicking on HA2 will take us to the ESMAC page, where we can see that this node is a hot standby. Let's go ahead and run the application. We connect our TN3270 session and run the bank transaction, which starts up BankDemo. We sign on and transfer some funds to update the file. Now we will simulate a failure in our high availability group by bringing down the primary node. As we can see, both HA2 and HA3 have detected that the connection to HA1 has been lost. They will wait a short time to see if they can re-establish the connection before resuming the failover process and assuming the role of primary. In this case, HA2 has taken over and performs PLT processing to open the necessary files, and HA3 now establishes the new primary as HA2. Looking in ES Monitor and Control, we can see HA2 is successfully marked as the primary, and the control page has been updated to show that the connection to HA1 has been released. Now going back to our TN3270 session, we can see that the user can continue to run transactions and has no knowledge that any failure has occurred, whilst files have still remained in a consistent state. Now, after investigation has been done on the cause of the failure, we are ready to reintroduce the region to the group. To do this, we simply need to restart the region. The other nodes in the group will determine that the connection has been re-established and begin shipping the transaction logs to update the data files. Once this is completed, the node will successfully rejoin the group as a standby, ready to assume the role of primary should another failure occur. That concludes our high availability walkthrough using BankDemo. We hope this has been useful to you.